got the 12S PCB in. It is working fine. This is the one that has the actual control element here and an 8-position connector and a fuse. And this is high voltage, and it has this safety isolated thing here. Don't worry about the wiring right now. It's kludged together just for prototyping. Right now we're pushing 50 watts in, 136 volts, 0.372 amps. It's about 51 watts. Yeah, it's working pretty well. Right now I'm testing the 18S plus minus, and with the 18S plus minus, the heater boards are actually far away from each other. And next I'll be testing the 18S minus minus, in which case the boards are butted right up next to each other. It might be the other way around. I'm testing one of the configurations now. I'll test the other one later. Anyway, it's going well in this configuration. This is one I wasn't particularly worried about. The big question is the middle module getting warmer than the outer two? And the answer really is no. I just took this cover off and the junction board just so I could look at it all now. So this is not how I'm testing it. It's just what it looks like right now. So 50 watts seems to be kind of the high end on what I'm going to want to do. It's probably what I'm going to do is 50 watts. One problem you have is that these boards end up starting to get quite a bit warmer, and it makes the cells start to have a very slight temperature gradient across them, like 1 or 2 degrees. And I just don't want to mess around with that. So you can see right now with this thermal camera that the PCB is about 65. It was 70 when I took the cover off. Granted, this is room temperature, 23 degrees C, but that's still a 50 degree temperature rise there. And it seems like, based on the testing I've done, I can't actually get to the high end of what these modules, what the cells will warm up to, because it's not cold outside. It's like 65 degrees out right now. So I need it to get cold again before I can actually see what the upper limit is. But these cells are, in general, they're heating up, 1 degree C every 5 minutes, maybe, so somewhere around there. Of course, that will not remain linear forever. Eventually, it will actually get to 0. The cells will not get any warmer. But it does seem like we get at least 15 degrees of headroom. So the cells can get 15 degrees warmer than the ambient. It's probably a lot more than that, but again, I can't really test it right now because the cells are getting up to 40 degrees C in my test area here. So next time it cools down, I'll hopefully have the finished PCBs done. I've made some minor changes, and that work is already finished. One of the things, when they remade this board, that it's not the right thickness. So instead of being 1 millimeter, it was 1.6. It's only on the 12S one. The 18S one was fine. But I think that they just kind of threw it on whatever plate they had. But yeah, no, it's working very well. This LED basically signals to you that it's on. Right now I'm using this lambda gen here just to turn it on and off. So if I turn it off and on, you can see that the current drops to 0 because it's an isolated switch there. And you can see here that likewise when I turn it on and off, that the LED turns on and off. It works great. I'm actually going to use this corner of the PCB on other projects because it's an isolated 12 amp 600 volt switching circuit with an 8-position connector and a fuse. That's going to be really useful down the road. I'm going to probably just cut this corner off the PCBs, and then I will just keep the chip here and use that for other projects I've got. I'll have 5 of them as soon as the Rev B PCB gets here. Other notes. Let's see. Yeah, nothing huge. JLC, I didn't like their stencils. They had additional cutouts that I did not ask for. Yeah, no, overall it's going pretty good. The only thing I still don't like is that in this configuration here, whichever one it is, the fan shroud, and I knew this was going to be an issue, but I just don't like how close the fan shroud is. Now this will be, it'll have a secondary shield over it here because it is high voltage. I haven't done that for prototyping here. It's just kind of how you doing. I don't like that. I was thinking it'd be neat if I could get an alternate mounting point here to where I could have the wires coming out here and there, and that way they can go through this hole. I think it might be hard to put the module in, but it might be possible. I'm gonna probably entertain that idea because I really don't like this. I don't want the, this is a sharp edge here, and even if this does have a jacket on it, that sharp edge is still problematic. So I don't really necessarily like that, particularly with the fan shroud, and particularly if people don't, say you do have to modify the fan shroud and people don't, that could be a problem there. So I am going to look for an alternate. Again, that's only one of the two configurations, but honestly, it seems like people are doing about half and half, 18S minus minus versus plus minus. So I'm gonna play around with that and just see if I can get some mounting holes in there, and then it would be probably a when you order it, tell me what version you're using, and I'll solder on the right wires. Who knows? I'm definitely wanting to wrap this project up because it's not particularly exciting for me. I don't really ever plan to use it, but obviously our cold weather users will need it, but I'm wanting to move on to other things. But fortunately, it's basically done. I will need to figure out the final wire links, the shielding, and all that, and I'll do that tomorrow. It's pretty late here. It's only 2:45 in the morning, which is, I went to bed at 5 yesterday. So, but I am tired right now. Gotta go to sleep. Just wanted to post this up. Unfortunately, I can't leave this on in my absence because I don't want the modules to cook. Even though all these cells are at 0 volts, these are dead ones that Prototype has sent me. Anyway, we will resume testing tomorrow, and I'll give you any updates if needed. Thanks for watching.